Good morning. Good morning to all of you. Is it audible? Hello? Is it audible?
So today in this class, we are going to discuss about the shear force and bending moments in the beams in Unit 2 of our strength of materials. And the other part of our unit is theory of simple bending. So what are the different types of beams? What is meant by beam? So here you can see in this image beam, a transverse member or a common structural element where all the three boys are standing over there. So due to this person, this load will be transferred to the beam. So how it transfers? So this is an example. What you are going to see here, seeing here, viewing it separately. So the reaction forces was it will go in the horizontal and it will turn to the supports which is held on it. So it is nothing but a device for transferring the vertical loads horizontally. So the action of beams involves the combination of bending and shear. So what is meant by bending and what is meant by shear we have to see. So the objective of this unit is to take up these beams, bending and the shear, what the beams have to do. It has to be very strong enough for the loads and it should not deflect too much and it should go for the size of the building or the material of the building, the surface finish and fixing and other properties. So to further calculation, we have just any object it has to achieve the static equilibrium. So static is the state of an object in which the various forces counteract each other so that the object remains stationary. So now we are just taking the only the cross section of the beam. So in this you are seeing the person which is seen at that particular point we have taken the cross section. So this is a person. So for that person we will be having the reaction force. And similarly, we'll be having the horizontal forces on the left to right or right to left. Similarly, we'll be having the movement, counterclockwise movement and our counterclockwise movement. So all these forces counteract each other. Hence, the object remains stationary in the stable condition. So a beam, it should be in a static equilibrium to take up the various loads, whether it may be an horizontal loads or vertical loads or the moments. So all that loads it has to carry means it should be in a static equilibrium condition. So in detail you are seeing here this applied load which is applied at the center of the beam. So it is resisted by the forces from the beam supports. So the resisting force or the reaction forces is nothing but which is applied at the due to the support conditions we will be getting the resisting forces. These forces are called reaction forces. So before going in detail of this force and bending moment, we should know what are the different types of supports are there or can be provided. So the type of support here, the first one is a roller support, pinned support, third one is a fixed support. So what is meant by roller support? So these are roller support in the image you can see. So due to this roller support, we'll be having only one reaction force. So from the reaction force, the reaction forces from the supporting members in case of roller support will be having only the vertical forces that is Fy. In the case of the pin connection, we'll be having horizontal force Fx and horizontal force Fy. So two reaction forces from the supporting members will be towards the beam or cross section of the support beam. In the case of fixed support, in addition to the two horizontal force and vertical force, a movement will be acting on the fixed end. So these the support conditions, and for this support, we are having the three types of forces. So what are the beam types? So you will be having a simply supported beam, or a continuous beam, or a cantilever beam, or a fixed beam, or a prop fixed at one end, supported at other end, and we'll be having the overhang. So in the image you will be seeing the in detail. So these are long and straight bars, and here this will be having a one long load, which is load which is applied perpendicular to the longitudinal axis. So here this axis, and here you can see the overhang. So these are two supports. After the support will be the beam will be extended for some length. So that particular length, due to that length, we call it as an overhang beam. So the other beam here you can see one end of the beam is fastened with a wall, and we'll be having one load at the free end. So this we call it as a cantilever beam. So a simply supported beam. So where you can see a roller support also you can see visually, and one center load at the mid, which is load with the mid. So here you can see the fixed beam and the load at either at eccentric or at the mid we can apply. So the blue color shows the load, and we are fastening it at two ends. So this we call it as a fixed beam. And in case a continuous beam will be having a number of supports, and the beam will be fastened or fixed at whatever it may be, depending upon this condition. So this we call it as a continuous beam. So the classification of beams is cantilever, simply supported, fixed beam, continuous beam, and overhang beam. So this is the classification of a beams. So in this classification of a beams, how to draw this shear force diagram. So that is the objective of this unit. So before we have to idealize the condition of our beam. So that is the applied load and the beam diagram should be resolved. So that diagram only we call it as a free body diagram. So here we are having only the applied load, and the reaction forces only will be drawn in the arrow representation. So the supports, whatever it may be, depending upon the type of supports, the reaction forces will be mentioned in the arrow. So if it is a roller support, we'll be having only one reaction force. If it is a hinged support, we'll be having a two supports, hinged or pin support. So the fundamental principles of equilibrium here is we have to first satisfy the sigma vertical forces, all the summation of all the vertical forces should be equivalent to zero. Summation of all the horizontal forces should be equivalent to zero. Summation of all the moments should be equivalent to zero. So these three conditions should be satisfied to solve our particular any problem. So a linear reaction is called as a shear reaction. A rotational reaction is called as a moment reaction. So the reaction forces will must balance the applied forces. So that is the purpose of our reaction forces. So what is a moment? So here you have a cantilever beam. A moment is created when a force tends to rotate an object. So the magnitude of the moment is equal to the force times the perpendicular distance. So here we have applied force F. We want to know about what is the M. So M equal to moment equal to the applied force F into the perpendicular distance. So your product of the F into D will be giving you the moment M. So this is a beam which supports a load that comes from this area. So these are the some of the applications of our beam, how it takes up the load. So here you can see this white color is a beam, one part of a beam, which takes up this load. Here it is area. So if I'm placing a refrigerator or washing machine over in this location, so it will be shared by this in this particular span only. So the load which is being kept here will not be shared at the other part of the beam. So how to calculate all the loads for on this kind of support conditions. So assume here we are placing a dead load on a beam on a support. So we are just calculating the volume of this multiplied with the weight per cubic meter will be giving you the load. So the total load of this beam, entire beam equal to area, product of the area, light load plus dead load, and in addition to this we will be having the self weight. So what are the different types of loads and beams we can have? So here in this picture you can do two categories of the loads, point load and distributed load. So due to these distributed loads or point load, we'll be having all the other support reactions which is occurred at the support. So if this load is varying, in this case of distributed load, if it is varying, if it is called as a uniformly varying load. So what's the loads will be do for the beam? So the loads are reaction bend the beam and try to shear into it. So this is the thing what you can see. Due to the application of the load, you can see the bending which takes place. So this is shear which can take place. So the points which are very near to the application of the load, we can see is C. We can see it is called as a compressive stress. The points which are away from the point of application of the load, there we will be having the tensile forces. So these beyond this neutral location of our longitudinal axis will be having a tensile forces. Between these curve will be having the compressive forces. So this is the other image where you can see the shear which can take place. So taking into consideration all these things, in architectural there's importance of the design beam plays a main important role. In some cases in our machineries, the pin connecting engine parts where we'll be having the heavy loads and the shear is a playing important role in all these cases. For example, pin connecting engine parts, we have to do a lot of things in the case of the designing of the beams. So generally, if you see beams in welding is designed for bending and it's for shear. So this is the concept of our designing of beams. So the next video will be just seeing how to draw the shear force diagram. So with this, in this video, we'll just end up balance in the next video.